and I'll go ahead and start the presentation. Again, I would encourage folks to type their name and agency in the chat box as they have a chance here early in the webinar. I'm Robert Zeal with the Lake States Fire Science Consortium. I want to point out that, in fact, we are an outreach arm of the Joint Fire Science Program, which is a national program based out of Boise. And our role is to bring science to practice in fire management here in the Lake States. Today, we are pleased to bring Stephen Handler, who is going to present some of his work related to climate change. I will point out first a little bit about the webinar interface that we have. It's different than what we used last year. You can see that it's very similar in format, that there's an area on the upper left that identifies where it identifies the participants in the webinar, and there's also a chat box in the lower left that I see most people have found where you will type in your questions. If you have them, I'll be tracking that throughout the webinar, interacting Stephen where it seems appropriate, and helping him answer those questions at pauses and interludes as we go along. I assume there will be a few moments at the end to clean up questions and take further comment. But that's really how this is going to go today, and I look forward to what Stephen has to say. A few minutes more about our consortium. We've been around since the fall of 2010. This webinar series is something that we started in the fall of 2010 and have been rather pleased with participation in that. Our goal is to bring a broad range of topics to the community in hopes that it will spur them to look at the science and see if there are things they can employ in their jobs when they go home. We do produce monthly newsletters and make regular announcements like the ones that you received today about this webinar. And we are working on other projects such as producing a fire science publication database that we hope to see go live on our website in January. So there's things that will continue to go on. I urge you to visit our website, lakestatesfiresci.net, and sign up for our newsletters and announcements, and that you take a look at those on a continuing basis to see if, in fact, there's something for you. With that, I will go ahead and introduce our presenter and his topic. Stephen Handler is the climate change specialist for the Northern Research Station of the Forest Service. He's working from Houghton, Michigan. He's responsible for developing the Northwoods Climate Change Response Framework. It's an expanding an effort that began with the Chequamegon-Nicolet National Forest and now includes the 6 national forests across the Lake States. You know, part of this effort that he's working on involves preparing climate change vulnerability assessments on forest ecosystems in the region. These assessments incorporate downscaled climate projections, ecosystem model simulations, and manager input. And boy, Stephen, I sure hope you'll give a little more detail. That was quite a mouthful. Future wildfire conditions have been one of the trickiest factors to consider. You know, how might climate change influence wildfire frequency, severity, or extent? How might the fire season shift under future conditions? And how might these changes interact with changes in forest vegetation? So this webinar really will be a discussion focused on encouraging us, the fire community, to engage in the topic and certainly help him explore the impacts on the fire community. So with that, Stephen, I'll turn it over to you and take it away.
Thanks a lot, Robert, and thanks to all you folks on the webinar. I was really excited to see how many folks have logged into the webinar here, and there's obviously a lot of interest in this topic. I guess before we start, I should make some announcements in the interest of full disclosure. So I'm not the only climate change specialist with the Forest Service Northern Research Station. There are lots of us around and working on this subject from various angles, and I'm also part of a much bigger team working on this effort called the the Northwoods Climate Change Response Framework. Now, I'm not a fire scientist, and I don't work in fire exclusively, so please bear with me through this webinar. Part of this, actually, the main reason I'm interested in doing this webinar is to hear your thoughts and get your input from those of you actively working in the wildfire community. So I will save some time for discussion. Please feel free to get in touch with me through the chat box here. I'm sure Robert will interrupt me, or afterward with any lingering questions. So just briefly, Robert mentioned I do work as part of the Northern Institute of Applied Climate Science, or NIACS. We're based here in Houghton, Michigan, but we have staff members around the country in Minnesota, California, and Michigan. We're an interesting hybrid of federal and non-federal partners coming together around this idea of creating a bridging organization that's devoted to getting knowledge into practice, focusing on 3 topic areas: climate change, carbon, and bioenergy issues. So our organization itself is a big partnership effort between the organizations you see here. Let's see, I'm going to move this arrow out of the way. So why am I here today? First of all, I want to share some info with all of you about an effort that NIACS is coordinating across the eastern U.S. called the Climate Change Response Framework. Second, I'll explain our process for evaluating forest ecosystem vulnerability to climate change, and also cover some of our stumbling blocks for incorporating wildfire considerations into these vulnerability assessments. And then finally, and throughout, I hope, I'm planning to get your input and advice. So we can pause this presentation at any time, or again, please follow up with me afterward. So essentially, the importance of forest ecosystems in the eastern U.S. is what is driving our work on climate change adaptation. Forests in this region sustain us ecologically, economically, culturally. They're a big percentage of our land base here in the lake states in particular. Michigan is over 50% forested. Wisconsin and Michigan are each above 30%. Hundreds of thousands of jobs are represented in the forestry sector, representing billions of dollars of economic output. Forests are also home to a wide array of forest-dependent wildlife and other forms of biodiversity, recreation and cultural connections, carbon storage. Each of these ecosystem services is in itself a reason enough to care about forests and to work towards making them resilient in light of climate change. Now, folks who are responsible for managing these forests, whether they're on federal, state, county, private, or tribal land, you name it, are used to considering these ecosystem services and kind of balancing their importance when making decisions and planning. Obviously, there are different priorities for each individual landowner or agency, and that makes forest management a complex arena. But the point here is that forest managers are already required to juggle a lot of these concerns over long time scales, dealing with uncertainty, and also responding to unplanned events, such as you see down here in the lower right. That's a photo from the big blowdown event that happened in north central Minnesota this past summer around the Chippewa National Forest. Now, forest managers are being asked increasingly to consider climate change among the many variables they already deal with. How will their activities affect carbon budgets in forest ecosystems? Or how will climate change influence the success or relevance of their objectives? Now, these are great questions, but there are challenges that make climate change information tough to consider in forest management. One of these major challenges is the scales the scale of information that climate change data is usually presented at. Typically, when we're absorbing information about climate change, it's coming at a global or national perspective. And there's a disconnect there when forest managers are working at the forest and stand level. Now, this isn't to say that climate data needs to be displayed always at the stand or micro scale, but just to recognize that it's a disconnect oftentimes. Second challenge we face when we try to incorporate climate change considerations into forest management is these long time horizons that we're used to seeing when we see maps like this of climate change projections that are out towards the end of the century. That's kind of a common basis for comparison for climate data when forest management plans are typically written with an eye for the next 10 to 20 years. A third barrier in incorporating climate change considerations into forest management is the uncertainty that's inherent in grappling with these future projections. Now, a lot of this uncertainty in what climate future may arise has to do with choices that we as humans have yet to make. What's our level of greenhouse gas emissions going to be in the future? So we're dealing with a couple different future scenarios of human activity, and then on top of this, climate models that are simulating the global climate system have different ways of incorporating this information and different processes for simulating the climate system. Some of the models work better for different parts of the world, and so on. So on top of this input data uncertainty, there's also kind of a processing technical uncertainty that yields some pretty wide differences in climate change projections, and that's a tough thing for forest managers to grapple with at times. And finally, the last barrier I'll mention for incorporating climate change considerations into forest management is this thing I'm sure we're all guilty of from time to time, and that's just being clear with science information. Our communication is not always perfect, and information is not always delivered in a way that makes it relevant for management decisions. So in order to address some of these challenges and help forest managers incorporate climate change considerations into their work, NIACS and other partners have developed what we're calling the Climate Change Response Framework. It's a broad effort that is a collaborative approach among scientists and managers and landowners. And the outcomes are tools, information, and some localized partnerships to support climate-smart conservation and management. Now, when I say climate-smart, I'm using that as kind of a catch-all term that just means that conservation and management should take a heads-up view of climate change. It should acknowledge and actively try to prepare for climate change rather than leaving it out of the discussion altogether. So what's climate smart for one person and one manager may not be, the same thing might not be the ideal response across all ownership types. Where are we working with the Climate Change Response Framework? We have 3 regional projects. It looks like some of my graphics aren't coming through here, but the map is on there. Rob mentioned earlier this effort called the Northwoods Climate Change Response Framework. This one started in northern Wisconsin with a pilot on the Chequamegon-Nicolet National Forest and expanded to the whole Northwoods region in 2010. You see there other states and regions we're working on with partners in each place. Now quickly, I just want to go through some of the main components of the Climate Change Response Framework. These 4 main components are what has evolved as the project has matured, and all of these components are kind of related and build off of each other in each place where we work. And the first, which I'll spend most of the time talking about today, is vulnerability assessments. In each place where we work, we try to distill a lot of climate change and ecosystem information into a clear report that is it's designed for a professional audience, professional forest managers across all kinds of ownerships. Our focus in these reports is forests in particular. You can see a first edition of these vulnerability assessments for northern Wisconsin, and we have new versions in progress for northern Minnesota, northern Michigan, and also northern Wisconsin and the western UP. Also, down in the central hardwoods region, we have a vulnerability assessment in progress. I'll come back to vulnerability assessments in more detail. The second component of the climate change response framework, where we really invest a lot of time and energy, is building and developing working partnerships on this issue of forest management and climate change. Partners help determine where we work. They help determine what the key questions are in each place that managers are looking to have answered. And they're also our main outlet for implementing climate change adaptation demonstration activities. So in each place where we work, we are either working through existing forums, such as case with the Minnesota Forest Resources Council in Minnesota, or building new forums for partnership on this topic, such as the Shared Landscapes Initiative in northern Wisconsin. I can answer questions about our involvement with either of those if people have questions later. In terms of actually getting managers some tools that they can apply and use to start incorporating climate change into the way they plan and manage forests. This is an example of a tool we've produced, Forest Adaptation Resources. It includes a menu of adaptation approaches and strategies for forest managers, and also a workbook process to kind of lead managers or planning teams through a structured decision-making process to consider climate change information and how it affects your particular objectives. It's not a recommendation guide. It's not some chiseled stone tablets with commandments for climate change information. It's more of a process document. And we're using that tool to develop a network, kind of a roster of pilot projects for climate change adaptation right now across northern Wisconsin. We're starting one also in northern Minnesota, so we hope to have a growing roster of these real-world examples of what climate change adaptation looks like in practice. And this is really what the project is all about, working with forest managers to help them meet their objectives by incorporating climate change considerations. Now this is a good time to pause. That's probably enough background about the climate change response framework. If anyone has any questions about the project, please chime in now. Otherwise, I'll dive into the weeds a little more.
Well, I don't see any questions typed in at this point. Do I understand correctly that you did have a couple of workshops this past year, one in Minnesota and one in the northern lower peninsula of Michigan, where you brought folks together to talk about these response frameworks?
Yeah, exactly. That's the piece I'm diving into next, is our process for doing these vulnerability assessments.
All right. Well, I'll step back and we'll let you take off again then.
Okay. Yeah. So a little more nuts and bolts about how the approach that we at NIAX have come up with for completing these vulnerability assessments and getting a look at how forest ecosystems may be at risk or may be likely to change over the coming decades. So this is kind of just a schematic of the pieces that come together to build these vulnerability assessments. There's a lot going on here. So I'm just going to do a quick drive through these components so you can see what kinds of information we are trying to assimilate into a coherent document. Now the first in the lower left here, current conditions, we do spend some time compiling information to set the context in each place where we're completing a vulnerability assessment. So things like forest ownership patterns, current forest health issues, community descriptions for the forest systems in each place, things like that. So just some of the basics to set the stage. Then we bring in observed climate trends. These are data from the PRISM network and the Climate Wizard tool. I'm not sure if anyone is familiar with the Climate Wizard tool, but it's a great way to illustrate observed climate trends at a scale that's more meaningful for forest managers. So here you see winter temperature trends from 1901 to 2006 in northeastern Minnesota. And we can break this down a bunch of different ways: means, minimums, maximums, and so on.
So what are these actually telling us in this case? Is it a change? Is it a depiction of change?
Yes. So these maps in particular are showing the change over this 106-year time span in northern Minnesota. This is based on a regression of the time series data, and it's showing you that minimum temps across this assessment area are have risen faster than means or maximum temperatures for the winter months. So I won't go into all the temperature data in detail, but I just wanted to give people a sense of the kind of information we're bringing in to these vulnerability assessments. Next piece is looking forward to a range of climate change projections. So we take the approach of using kind of a bracketing method. So we pick a kind of a high or an extreme climate change scenario that's based on a more aggressive greenhouse gas emissions scenario combined with a more sensitive climate model to represent a picture of the upper end of change. And then we also pick a more mild emissions scenario paired with a less sensitive climate model to get a sense of a low end of change. And this shows, again, that range of potential climate change for this assessment area. These data are based on downscaled climate data that's available at the USGS Geodata portal, and I'm happy to share that link with any of you if you want to investigate this data source. We have, again, daily downscaled temperature data and precipitation data from this source. We also bring in other published research on climate change projections in terms of extreme events and other trends. Also things like you see here, snow water equivalent under different climate change scenarios going forward into the future. So here you see substantial decreases in snow water equivalent by the end of the century under both a mild and an extreme climate change scenario. I'm also happy to share some of the papers we have related to this. We also have, from similar sources, data on precipitation and evapotranspiration across seasons. So we're trying to get a sense of not just temperature change, but whether seasons will be wetter or drier than today. Okay, so on top of this climate change data, we also incorporate results of a couple different kinds of forest ecosystem models. This is just a snapshot of outputs from Landis, which is one of the models we're using to create scenarios of future change in forest ecosystems. Landis is a dynamic simulator model that grows cohorts of trees and lets those cohorts reproduce, compete, migrate, experience disturbances. And this is just a snapshot showing biomass across the landscape, that same map that you've been seeing for northern Minnesota over time for these four species. This is just an example of the kind of results that Landis produces.
Stephen?
Yes.
Just maybe as an example, the jack pine seems to have the strongest downward trend, and the red pine seems to have the strongest consistent upward trend. What do those trend lines actually tell us about those species?
Well, again, this is biomass across that whole landscape. So this is saying that across that northeastern corner of the state, that total landscape level biomass of jack pine is likely to decline under both a low and a high climate change scenario, whereas red pine is likely to either be stable or show an increase under that range of futures. And I purposefully didn't put all the legends in here and stuff. I just want to give people a sense for the kind of information we're pulling in.
Sure. Thank you.
I'd be happy to share, we have summary results from all of these modeling efforts that are being done by our partners across the country that I'd be happy to share with the group.
Okay.
One more, I won't go into detail about all the models we're using, but one more model that I wanted to share with y'all is Tree Atlas, Climate Change Tree Atlas. This model produces maps like these and tables that forecast suitable habitat for individual tree species in the year 2100. So this is not a prediction of where trees will actually, not a prediction of whether trees will actually migrate to these locations or die in areas where the suitable habitat leaves, but it's an indication of where these species may be growing inside or outside their ideal envelopes, potentially creating stress for species left outside or left behind their suitable habitat as it changes. So you've seen some of this, some very quick snapshots, I know, of climate data, ecosystem models that we're running to support this vulnerability assessment. We don't just take these model results and drum up an algorithm to determine vulnerability of forest ecosystems. These are complex systems, and there's a lot of information, drivers, and experience that aren't represented by these models. So we take a deliberate step to incorporate local expert knowledge to try and distill some of this information with professionals from across a wide cross-section of the forest management community. So, we hold these workshops that are essentially like structured discussions to lead folks through considering this information, bringing in other published studies that they're aware of, also their own management experience and kind of expert input. You see here a picture from a workshop we had in Grand Rapids this past summer with folks from a wide range of organizations. So I don't need to belabor this point, but wildfire is a major disturbance agent and a driver in some of these forest ecosystems we're considering in the North Woods. Whether it's fire-dependent communities in northern Minnesota, jack pine barrens in Michigan, oak savannas in Missouri, down in the central hardwoods. It's necessary for us to try and account for wildfire activity and potential changes in wildfire activity in these systems, and to think about how climate change is likely to influence wildfire. But this has been a bit of a stumbling block for us, honestly. So that's kind of the intent for this webinar, is to show you all some of the information that we are aware of and show you kind of where our thinking is currently, but then also pose some of the hanging questions that are out there and maybe just start a discussion, or maybe there are already answers out here to some of these questions. So let me just start out with a couple general principles. This probably won't be anything new for most of you on this webinar. One thing that is clear is that climate change can influence fire directly in three ways, whether it's altering fuel conditions, changing the characteristics of fuel loading on a landscape, or changing the probability or occurrence of ignition. And so this is a figure from a paper by Max Moritz and colleagues, kind of showing how climate change, or climate in general, can influence wildfire. They put this, in the centerpiece, they put this kind of core, the hot red of that dot represents the fire activity from long-term averages in climate, where kind of the outside of that inner circle is fire activity that's controlled by year-to-year variability. So that kind of gets in two layers of thinking that climate is definitely, by definition, is patterns, long patterns over time, where interannual variability may still have a profound influence on fire activity. this leads to, the caveat that that you have to be clear about attribution when you're talking about climate change. You can't say that climate change is directly causing any particular fire or weather event. I know I don't need to tell any of you that. And I really like this analogy. I've been hearing more about steroids and home runs. You can't say whether steroids made it any more likely for a baseball player to hit a home run, but you can say that steroid use over a player's career may kind of change that baseline probability that they're going to hit a home run at any at-bat. So that's kind of how we are thinking about climate change and wildfire, how we caution people to think about climate in general and extreme events. I've drawn a lot of information from this synthesis report by William Summers and other folks on kind of broad principles.
Stephen, can I stop you for just a moment?
Sure.
At my location, I've lost internet connectivity. Charles, are you still seeing the presentation? I don't know, Stephen, if anyone has reported on the chat box whether or not they've lost connectivity. It might just be my problem.
It might just be you. Michelle Richards says it's okay here. Tom Brock says okay here. Greg,
okay.
He says, I am Zeke.
Okay, well, I'm going to need Charles to help me track the questions then.
Okay. Okay, great. Okay, so if for those of you who haven't seen this report or are interested in getting a really comprehensive synthesis on how climate in general can influence wildfire and then how climate change might potentially influence fire activity, I would recommend starting at this report. And so here we get lots of ideas about fire's influence extending over long time scales, broad spatial scales from local to regional, and that also that the fire regime response to climate change may vary considerably over time and space. But ultimately, a couple of their concluding remarks here in this report are that fire will likely be a catalyst for change in vegetation, perhaps prompting even more rapid change than you might expect based on changes in temperature and moisture alone. So fire may be an intensifier or an amplifier in some places of change. And so fire may be more important than the direct effects of climate change on species fitness or migration, which is an interesting thought to think about. We've seen, particularly in the Northwoods, we're relying on a good batch of information that's been produced for boreal forests. It seems like there's more fire research out there for boreal and western systems. Correct me if I'm wrong there. Some of the projections we've seen for boreal forest systems project potential 100% increases in areas burned due to wildfire, 50% increase in wildfire occurrence by the end of the century, and basically raising this question of whether fire management will be able to keep pace with fire activity as we get into further and further into the 21st century. Also, there's a seasonality or a timing hypothesis that seems to be emerging that the fire season will or may shift later into the season. So fire risk in August may become much more high or much higher, while fire risk in May, earlier in the springs, may decrease. And that's consistent with some of the downscaled climate data we've seen that shows potential for much wetter springs and much drier summers. Another interesting paper that we came across just recently had to do with drought in northern Wisconsin, so a paper by Brian Miranda and colleagues in northern Wisconsin confirmed that drought described by the PDSI was shown to be a major driver of fire occurrence and size in this landscape in northern Wisconsin, but also that at this point humans might have a larger influence on wildfire activity than biophysical drivers alone. So our patterns of landscape management, fragmentation, urbanization, things like that, those might have as much or more of an influence on wildfire activity going forward. And then one final paper I wanted to show briefly the results from is, again, this paper from Moritz et al. Looking at, so they did a synthesis of 16 or 20 different climate models and looked at how well all of those different climate models agree on near-term and long-term changes in wildfire activity. And so there's, let's see, yes, that came through. So for temperate coniferous forests, broadleaf forests, and boreal forests, what you see is basically comparing near term, that's 2010 to 2039, to further out into the future, 2070 to 2099. For these three forest types, you see kind of a shift towards more agreement for a likely increase in wildfire weather, wildfire-related weather patterns. So while models might be kind of split decisions for near-term changes in wildfire activity or weather that may promote wildfire activity, most of the models are in agreement towards the end of the century that these forest types are likely to increase in wildfire. Okay, and then for those of you who aren't familiar with the Climate Change Resource Center, I wanted to point you all to this page. This has a great library of information for forest managers and professionals. They have a topic page on wildland fire, and the summary is kind of, it's consistent with the results I've just been describing to you, that generally climate change is creating an environment that's more conducive to large, severe fires, particularly in boreal systems. They're also saying that they also do point out that climate change could also impact the fire occurrence probability, or through increases in lightning activity. But also they make the point in this Climate Change Resource Center summary paper that in the East, our spatial patterns of land use and our prescribed fire programs make these broad-scale predictions of area burned and fire occurrence more difficult than making those same predictions for the West. So they do point out our area of the country as a need for ongoing research. So going back to this vulnerability assessment process diagram that I put out earlier, I just wanted to prompt you all now with some of our lingering questions, and this might be a little weird to run this through the chat box screen, but we'll do what we can. I kind of want to point out some of our hanging questions in each of these pieces of information that are related to wildfire, and try to stimulate a discussion that way. So we'll see how this works with the chat screen. So when we start off thinking about our current conditions and our kind of our ongoing forest and fire management trends, in these expert panel discussions that we've had in Michigan and Minnesota over the last year, this question has come up regarding the ongoing trend towards mapleization of forests in our part of the world, and whether that trend will continue, and whether that in itself will make forests more fire retardant, I guess, in the future. So that's kind of an ongoing trend that might not be accurately represented in some of these models that predict wildfire behavior purely on temperature and precipitation values. There's also questions as to whether our current level of fire suppression will remain the same in the future, and on the flip side, whether we'll have more or less use of prescribed fire in the future. So those are all three big questions related to management and ongoing trends that make these future predictions a little more tenuous. Secondly, I just wanted to remind people again that there's often a big disparity between climate models with respect to precipitation. So this map shows differences in projected summer precipitation between our more extreme, that's the Hadley A1FI scenario, or the more mild climate change scenario. In this case, for northern Michigan and the eastern UP, actually the milder climate scenario shows drier conditions across the whole year. That's what you're seeing in this brown map up above. The Hadley A1FI shows much wetter conditions across the whole year. But then in the line graph on the left, when we actually look at summer precipitation, that extreme scenario is showing potential for greater decreases in summer precipitation than the mild scenario. So annual trends can mask seasonal trends. There's also a big difference between which future scenarios you're looking at. So that's a pretty big uncertainty for folks to grapple with when they're considering potential wildfire activity. And then when we're thinking about these ecosystem modeling outputs, for example, Tree Atlas, this model doesn't explicitly consider fire as a disturbance, only suitable habitat based on established relationships. So the vegetation changes suggested by these model outputs, if they actually occur and forest communities do change, how might that change fire behavior? If, for example, black oak moves up into northern Wisconsin and Minnesota and Michigan, will that modify our the flammability or the fire susceptibility or tolerance in these forests? Also, when we look at Landis as an ecosystem model, it does include wildfire as a stochastic disturbance. So it, as it's simulating trees growing and migrating over time across space, it does include fire periodically. But it's still a question of whether the fire parameters they put into that model will accurately match what's likely to happen in the future. And what will be around to colonize after these disturbances in real life may be different than in their model scenarios. And then finally, one last batch of questions I wanted to leave you all with is based on this idea of interaction. So how is wildfire likely to interact with other stressors such as forest pests, drought, blowdown events, invasive species, and so on? I don't think there's any model out there that will give you an answer on that question. And similarly, will fire frequency, extent, intensity, will all those variables change independently, or are they likely to all move in consistent or cohesive directions? And so if we experience more fire in these landscapes, how much fire is healthy and how much fire is too much? Okay, I'm seeing a question from Michelle. I'll go ahead and try and take this one. So is the Hadley high scenario suggesting that black oak is gone from that central area of the map. Great question. So in these tree atlas outputs, again, what tree atlas is telling you is just suitable habitat. So it's not telling you, for example, that black oak, all the mature black oak in northern Indiana are suddenly going to die and disappear by the end of the century. It's telling you that suitable habitat is shifting up into the New England states and up into the Great Lakes area. So those black oaks living in northern Indiana, they'll still be there. But what it's giving you an indication of is that they're growing further outside of their comfort zone, and they may be experiencing greater stress due to that. Okay, any other, so I know I threw a lot of considerations at you in those last couple slides. Does anyone have any questions or thoughts about any of those that I posed to you?
Yeah, so I am back with you, Stephen, so
okay.
I can help you field these. While we're waiting for some folks to type some things in, I have a couple of thoughts myself. As a longtime fire manager, it always seemed that my planning and managing time horizon was fairly short. It almost was a political time horizon, budget years, and really the kinds of things that affect my ability to manage an incident or a short-term program. We always wanted to have a longer time horizon, but that short horizon has always left us without the opportunity to think about these things off into the future. Is that something that you've heard from folks as you've had these meetings?
Well, we certainly hear that from the forest management community in general, that it's hard to accommodate these long time horizons into the necessity of doing everyday work, the practicality of the decisions you have to make as a manager right now or yesterday. From the fire management community in particular, I really haven't had that discussion with a lot of fire managers. I'm not sure if people are feeling, comfortable about or feel like they have a sense of direction for for fire priorities or budget expectations going forward, or if that's totally at the mercy of year-to-year politics.
Well, that one graph that you showed of the jack pine biomass going down certainly would give pause to the fire managers in the state of Michigan, where they have these large areas of jack pine growing on these outwash plains that have been fire magnets for whole careers. And if that declines in that way, how will those ecosystems look, and what will that mean to fire management is really something that I'm going to have to take some time to think about.
Yeah. Jack pine is an interesting one. We spent a long time talking about jack pine and jack pine barrens in Michigan at the expert panel workshop, and something that we kept running into is if even though the model may show decline in suitable habitat for that particular species, or may forecast a decline in biomass across the landscape, we also have to ask some questions about, well, if the models are showing a decline, what's likely to come in and outcompete jack pine on those sites, or what are they likely to change to, if anything? And jack pine was one where we feel like they had a little more resilience or adaptive capacity because of the fact that they're already used to dealing with these droughty, episodic conditions, nutrient-poor sites where maybe they won't get a lot of competition from new migrants. Those are the sorts of things we are grappling with in the panel.
Okay, so I don't, I'm going to continue with a couple more questions that I had, although I see Jay Charney here has just included one. You can see it here, but it says that ecosystem sensitivities to climate change is read recently about inverting the potential climate impact assessment. So rather than saying, here's what the models are projecting and speculating what might happen, some scientists are assessing which areas of elements of ecosystems might be most sensitive to changes. And that's sort of what you were just talking about, isn't it, Stephen?
Yeah, that's a great point, Jay. And no, we haven't explicitly considered that sort of assessment for this region. You know, you're right. You could kind of think about it on its head and say, well, if we get 3 inches less rain in the summer in the future consistently, what outcome is that likely to have, or which forest types wouldn't be able to tolerate that? And we haven't done that. In some cases, I think it's because some of those sensitivities and kind of climate envelope parameters aren't fully known. But in some cases, it's maybe just an order of operations kind of question. Does anyone else have any thoughts about that, or have you seen assessments that take that approach?
Well, I know it takes a little time for folks to type questions in.
Sure.
I think his question certainly speaks to the notion that, in fact, that may have been done in some other regions, and you know, certainly a consideration. I'm going to, as I wait for some of these other questions, I just want to see here. I see Michelle had a comment saying that some of the species-specific vulnerability assessments, it sounds to me like there's some interest being generated by those graphs that you showed about the individual species. But you said that there wasn't much fire participation in the workshops that you conducted.
I wouldn't say that. I mean, I was looking through the attendee list on the webinar here, and several folks on the webinar right now were at the webinar panel. So, you know, we had in Michigan and Minnesota, we had folks who were experienced in working with wildfire and managing forests in places that experienced a lot of wildfire. But it is a body of research that I'm not an expert in, and so we are looking for more input all the time.
Well, I have to say, from my own perspective, I've been rather skeptical of its importance to me in my job as a fire manager when I was still working for the state of Michigan, given the short time scenarios we're working under. But I will suggest that my own experience living in the Upper Peninsula of Michigan, living through Decembers in the last number of years where we've received rain instead of snow, and we, this past year, arrived at spring fire season without much snowpack due to low snow totals and then the early warm-up event. You know, whether or not that predisposed the landscape for the kind of fire conditions that we saw in the East UP, and whether or not that's related to the kind of impacts you were suggesting for the boreal forest, you know, I don't know, but it certainly has given me reason to pay more attention and think more about these issues. We do have a couple more questions come in. The Fond du Lac Forestry Group asked about the typical fire regime for black oak.
I have to throw my hands up at that one. I do not know, but we could look it up in the Silvix manual, or I could put you in touch with my colleague Leslie Brandt, who is she's the one coordinating the Central Hardwoods Climate Change Response Framework.
And I do think that following up on a couple of these questions makes good sense. Now, Michelle Richards asks, she says in Michigan, the Michigan DNR has completed the vulnerability assessments for animal species that are listed. While it doesn't cover habitat specifically, it does touch it generally and might provide more information for other people's work. Are you familiar with what she's talking about,
Yeah.
Stephen?
Mm-hmm. Yeah. Chris Hoving and other folks at Michigan DNR have, I'm not sure if the report is published yet or not, but they have been looking at a vulnerability assessment for a long list of wildlife species. And they, to my knowledge, they take more kind of a rubric or a checklist approach where you have a species and you kind of check whether you think it's susceptible to changes in different parts of its lifestyle, or whether it's migratory, and that might influence how susceptible it is. And basically, you come up with a rank score for each individual species. In a sense, that's a little bit like the approach Jay was asking about above. But you see that with a lot of wildlife vulnerability assessments. I could point people to a couple if there's interest in that, where it's more like, what's the species tolerance to a given set of temperature conditions, things like that.
Okay. I think we are reaching a point here where I want to re-emphasize the points that Stephen had asked about, and at least suggest some ways that people can provide some input. He talked about the mapleization of the forest, that when we harvest areas of oak and pine, that red maple seems to be a real invader, if you want to use that term. And it does change the flammability of those landscapes. He asked questions about what will the impacts be on our suppression programs. Will it require more or less funding? Will it make us more or less effective, I assume? And then finally, do we see more or less prescribed burning if there is the kinds of changes that they're talking about? I'd encourage folks to certainly email Stephen directly, and I think one of these next couple slides has your email on it, doesn't it, Stephen?
Yeah, I'll go ahead and bounce over to that.
And I would encourage folks to take down his email address and his phone number, and certainly share their thoughts about this, because I think you've heard here that there are different approaches to studying this, and also a wide range of possibilities that they're trying to prepare for. There are a couple more questions that came in. Paul D. asked, are there any thoughts why the significant increase in red pine landscape biomass? Did you explore that at all?
Yeah, let me go back to that. So this, again, was for that landscape in northeastern Minnesota. And what you see here, I didn't explain what all of these lines were, and I'll do that now quickly. The black lines on this graph represent current climate, so kind of our current climate regime just spun out into the future. Red represents the extreme climate change scenario, and blue represents that mild climate change scenario. Basically what you see here for red pine is that the way this model is spinning up is that even under our current climate regime continued out into the future, it's forecasting an increase in red pine biomass across the landscape. Now that may be to red pine potentially expanding its footprint in Minnesota, which has happened over the last couple decades, but also the cohort, the major cohorts of red pine that exist on that landscape growing older and maturing generally over time. Now in the high scenario, you see that kind of take a turn and level off under the solid lines. Those blue lines, or the dashed lines here, those represent a different scenario that the modelers put in. based on kind of adaptive silviculture. So they said, well, what if we started to do all sorts of climate adaptive silvicultural techniques across the landscape? I can give you more information about those and how they designed them, but I'm talking about the solid lines right now.
Okay, appreciate that. Yeah, I think that these certainly introduced some questions in people's minds that will cause them to think about this further. Ryan made a comment that as the one graphic indicated, fire frequency and intensity is part of a complex ecosystem feedback loop. When you have drought-prone soils, fuel loadings and landscape position, how do the models, and I think you may be talking about Landis in particular, but how do they take that complexity into account?
So I am probably not the best person to answer this question. Eric Gustafson, who's on the webinar here, could probably do a much better job. I'd be happy to put you in touch with him, but basically there's kind of like a separate extension in the Landis model that chooses how and when a fire is likely to appear on the landscape. So I believe they do account for some of the factors that you mentioned here when they're determining where's a fire likely to occur stochastically. They probably aren't able to do all of these to the full complexity that would be required, but Eric could I'm sure give you a better rundown.
Okay, well, and perhaps we may need to schedule him for a future webinar.
Sorry,
I would ask you, Stephen, to advance forward to your email address again.
Okay.
And I think we don't have any additional questions at this time. I will want to point out that we maintain the link on our webpage that has background information, Stephen's email and contact information, and we've mentioned several documents and publications and references, and I will gather those up with Stephen's help, and we'll add those to that page so that people can go back afterwards, find what he's talking about, and in fact, listen to this again. We have recorded this, and we'll maintain it on a link from our website. And so if you want to share it with someone else or go back and review a portion of it, it will be available for that. So we've had a couple of folks already say thanks. I certainly do as well. I found it very interesting and thought-provoking as we went forward through this. And I guess if there's nothing else, I do want to, do you have any final comments, Stephen?
So I know some of you are probably already looking at these questions or may already have good places to help us track down some of these answers. So please don't be shy about spamming me with questions or resources. That'd be great.
All right. Well, so I would like to close this out. We, as I mentioned at the beginning, we do monthly webinars throughout the fall, winter, and spring, and that our next webinar is presented by Dr. Matt Jolly from the Fire Lab in Missoula. He's going to be talking about what is live fuel moisture, a new look at the combustion of living plants. Now, we typically schedule these for the third Thursday. I moved it this month in honor of the opener of rifle deer season in Michigan. But next month it will be the third Thursday, December 20th, again at 2 p.m. Eastern, 1 p.m. Central. We'll be co-sponsoring that with the Alaska Fire Consortium. I would again encourage you to visit our website, sign up for newsletters and other mailings, and we'll do our best to keep you apprised of what's going on here in fire science in the Lake States. So with that, I will sign off. If there's no other further comments or questions, give you, Stephen, a moment to look at the thanks from different folks. And again, we do appreciate your taking the time to talk with us about this.
Sure thing. Thanks, everyone.
All right.